which means that that surface would be pretty smooth. So that's how friction works. Now, the second situation we have to work with today is an inclined plane. Now, what I mean by inclined plane is, well, a triangle. So let's draw a triangle right quick. Let's do it in blue. So let's say we have inclined plane, and let's say this right here is 30 degrees, why not? And let's assume that I have a box sitting on this plane and it's not moving at all. Now, if I were to ask you if that was a smooth surface, like a really, really smooth surface, what would happen, the correct answer would be, well, the box should slide down the plane. But if it doesn't slide down the plane, that means something must be opposing that movement of it to slide down, which in this case will be friction. Now, if I were to ask you to figure out, again, let's look, what is the coefficient of friction? What is mu? So if we were to look at this, the first thing we'd have to do is, like every problem, is to draw a free body diagram. And to ask yourself what forces act on the box. So the first force that would act on the box is gravity. So gravity would go straight down. And again, let's assume this is a 10 kilogram box. So we do need some numbers here, which would make this 98 newtons. Now, if this was the only force acting on the box, then the box would fly down through the surface. But it's not, because there is a surface there, which means there must be a normal force. But inclined planes is where normal force can get a little confusing. Remember that a normal force is always perpendicular to the surface. And perpendicular to the surface is going to be in this direction right here, because this is right angle. So if I draw in my normal force, it must be perpendicular so that this is a right angle. Now, we can't just say that my normal force equals my force of gravity anymore, because my force of gravity is going straight down and my normal force is not going straight up. It's going in this upward to the left motion. So we have to look at some other forces to figure this out. Now, I also said a second ago that if it was a frictionless surface, that it would slide down the incline. But it doesn't, and it doesn't because friction must oppose that motion between these two surfaces right here. Now, our next step, if we were doing this, would be to look and see if we have any diagonals. In this case, we do have a couple diagonals. I wonder if I can zoom in on this. Yeah, there we go. Alright, so I do have a couple diagonals. Those being friction right here and my normal force. So friction can be split up into a horizontal component and a vertical component, where this is 30 degrees, making this F sine 30. And this F cosine 30. And then my normal force could also be split up into a component here and a component there, where that is 30 degrees, making this n sine 30 and n cosine 30. Now, if we were to draw a component diagram of this, you'll notice it gets a little confusing. So I'll draw it out for a minute in a second, but we're going to go back and I'm going to show you an easier route. So just focused on this. If we had a free body diagram, we would have our box, we would have gravity going down, we would have two forces going up, one force to the left, one force to the right. So I know gravity goes down. If you look back here, my F cosine 30 goes to the right, so that would be F cosine 30. My F sine 30 goes up. My N cosine 30 goes up, and my N sine 30 goes to the left. We can kind of double check all these, and we see that. Now, we know this box isn't moving, so if I wanted to just set my equations, I could do that my force of gravity equals N cosine 30 plus F sine 30, and that N sine 30 equals F cosine 30. What you also are going to notice there is that we have two unknowns, and we have a whole lot of trig. This right here is not an easy problem. So, we're going to do a little shortcut that's going to simplify this. And I'm going to go back, or I'm going to draw out a new triangle again, just to make it easier for you. Alright, so here's our triangle. There's our box. There's our 30 degrees. We have gravity that goes down. That was 98 newtons. Normal force that goes up, perpendicular to our surface, and then friction that goes this way. There's no other forces here. Gravity is what pulls us down the slope. Kind of partially gravity and partial a component of the normal force pushing down the slope. And the reason we've been splitting things up into these horizontal components and these vertical components is that it's easier to think of it when we're in equilibrium, say ups equal downs, ups equal rights. But we don't necessarily always have to split them into horizontals and verticals. We have to split them into y components and x components. Now, horizontal and vertical is easy if we just say that y is vertical and x is horizontal. But these right here are completely arbitrary coordinate systems. I can say that y goes this way and that x goes that way, as long as they're perpendicular. It doesn't matter which way I set one axis, as long as the other axis is perpendicular to it. So what we're going to do to simplify this is we're going to say that my y-axis is perpendicular to our slope. There's going to be our y-axis. And then my x-axis is parallel to the slope. And this is fine, as long as these two axes are at right angles, then whatever goes up in the y direction must equal whatever's down in the y direction, and whatever's to the right in the x direction must equal whatever's to the left in the x direction, as long as we're in equilibrium. Now, if we set our axes in this direction, then my normal force is already moving in my y-axis, so it's good. My friction force is always moving in the x-axis, so it's also good. The only thing I need to split up is gravity. And gravity can be split up into two components. One component going in my y direction, one component going in my x direction, just like this. Now, when we triangulate it, our angle is going to be right here. So that's going to be our 30 degrees. The reason that that's 30 degrees is because if you notice that my gravity goes down right here, this is 30 degrees, this is a right angle, so that makes that 60 degrees. This is also right angle, so they're basically complementary, I believe. Now, since I've split gravity up, I have an opposite component and an adjacent component. My opposite component will be down here. This will be mg sine 30, and my adjacent component here is going to be mg cosine 30. So when I draw a free body diagram of this, I have my box. Notice I'll leave my box on the incline. It makes it easier. I have my friction going up in the x direction. My mg cosine, or mg sine 30, excuse me. mg sine 30 going down in the x direction. I have my mg cosine 30 going down in the y direction. And I have my normal force going up. So, instead of our earlier situation, which I'll go back to, where we have multiple forces with, or multiple forces in each direction with multiple different variables, in this direction, or with adjusting my axes, it makes it a lot more simplified. So I can say that N equals mg cosine 30, and that friction equals mg sine 30. Now, I asked you earlier, what was the coefficient of friction? So to understand the coefficient of friction, I need to know my normal force. And in our original picture, I gave you the normal force, or the force of gravity was 98. So to solve for my normal force, I can just say, hey, N equals 98 sine 30, and we can multiply that in the calculator, and normal force becomes 49 newtons. And that is a lot easier than dealing with that, trust me. And then once I know my normal force, I know that friction equals mu n, so I can take this and I can plug it in right there because this friction and that friction are the same. So I get that mu n equals 98. Ooh. I just made a mistake, guys. I'm sorry. This right here should have been cosine. Which means that this normal force is not 98 or 94. What happens when I make videos that get going too fast sometimes. That means this normal force is going to be 84.9. Sorry about that. I can't go back and erase. So, just make that note. This right here should be normal force. So, sorry for that. When I plug in my friction equals mu n, here for friction, I get that mu n equals 98 sine 30, which in this case, this is 49, if you type in the calculator, and my normal force is 84.9 newtons, so my coefficient will just be 49 over 84.9, which looks to be a little bit less than 0.5. Excuse me, more than 0.5. 0.58. So, by going from having our axes being up and down to left and right, or to perpendicular and parallel, I can simplify my free body diagrams or my components a little bit and make the math a little bit easier. Now, we're going to try some more on this on Tuesday and Wednesday, so if you get lost, kind of try to follow through the video again a couple times. But we'll work through some more of this in the next couple days. We'll see y'all soon.